Hello everyone, my name is Anand Suthar and welcome back to another episode of my LeetCode Problem solving series. Today we are solving a find first and the last position of element in sorted array. LeetCode Problem number 34. This is the classic binary search problem with a twist. Instead of just finding the target, we need to find the first and the last occurrence. And since the array is sorted, binary search is the way to go. But we need to modify it slightly. Let's dive in. Here is the problem. We are given a sorted array of integers and a target value. We need to find the starting and the ending position of that target. If the target is not found, we return -1 and -1. Understand this with an example. We have given example 1 with a nums array and target is equal to 8 and its output is 3, 4 as 8 appears at the index 3 and index 4. Similarly in example 2 as target 6 do not exist in array. The brutal force approach would be to scan the entire array O n time, but since array is sorted, we can do better with binary search O log n. The challenge binary search normally return any occurrence, not the first and the last. So we need to modify binary searches, one for left boundaries and one for right boundaries. Here is the strategy step by step. In step 1, we find the leftmost occurrence of a target using binary search. How, when we find the target, instead of returning immediately, we store that index and continue searching on the left side. This ensures we get the first occurrence. In step 2, find the rearmost occurrence of the target using binary search. Similarly, when we find the target, we store the index and continue searching on the right side. And in step 3, return both index right and left. And if target is not found at all, both searches will return -1. Let me show the code. We start inside our function search range. The first thing we do is declare the vector called result, initialize it to -1 and -1. This acts as our default answer if the target is never found. Now let's find the first position of our target. We set up our two binary search pointers I at the very beginning of the array and the j at the end of the array. We kick off our first standard while loop, which runs as long as our pointers have not crossed each other. Inside we calculate our mid using I plus j minus I divided by 2 instead of I plus j divided by 2 is a next trick that prevents the potential integers overflow bug. Here is where the magic happens. If the value is now mid matches our target, we do not stop. We long this index into result because it might be our starting position. But since we have not find occurrence, we force our search to keep looking at the left. We do this by dragging our right pointer j to mid -1. The rest of the loop is a standard binary search. If our middle number is smaller than the target, we cut off the left and a half by moving I to mid -1. If it cuts larger, we cut off the right half by moving the j to mid -1. Once this loop ends, result 0 will hold the absolute first index of our target. Now we need to find the last positions. We completely reset our position I goes back to the beginning and the j goes back to the end of the array. We spin up our second search loop and recalculate the mid exactly like before. Pay close attention to this block. If the num at mid equal to target, we save this index into result 1 because it might be our the ending point, but because we want to last occurrence, we force the search to look at the right. We push over the left pointer I forward to mid +1. Just like before, if the middle element is the smaller than the target, we move I up. If it's larger, we move j down. Once the second loop wrap up, result 1 safely holds the absolute index of our target. Finally, we return our result vector containing both insets and we are completely done. Its time complexity is O log n. Each binary search run in O log n time. We run two of them, so total is still O log n. Space complexity is constant. We only use a few variables, no extra spaces. Let me submit this and it passes. That is the find first and the last position of element in the sorted array using two modified binary searches. If you found this helpful, please like and subscribe. I am Anand. Thanks for watching and I'll see you in the next problem.